Chemists often use chemical formula instead of words, and chemical formula gives us so much more information than just the word. It tells us what elements are present, but it also tells us how many of each element is present as well. The first thing we'll look at here in terms of our chemical formula is capital versus lowercase letters. Each element will start with a capital letter. That is important because some elements will have 2 letters in their symbol, whereas other elements will only have 1. So take for example CO. CO is the chemical symbol for cobalt, and you can find that from the periodic table. But you will notice that the first letter is a capital, and the second letter, the O, is a lowercase o. So that tells you that all of this is one element. However, if we change that to CO, where both are capital, this now is carbon monoxide, where we have 1 carbon and 1 oxygen. And you can see here that these are 2 things which are combined together because there's no space between them. Formula can get more and more complicated. So here's another example where we have Na, which is sodium, O, which is oxygen, and H, which is hydrogen. But we can see each element present by the capital letter. So each time you see a capital letter, you know that that is going to be a new element. Sometimes in our formula we will see numbers. So for example, here is H2. This little small subscript 2 after the H tells us that there are 2 hydrogens. It's important that you always keep this subscript. That means a number below the level of the line. In maths, you may put it at the top of the line like this. So for example, A squared, but that means something different. We will use the top for something else later on, so don't do this in chemistry. When it comes to our formula then, we might have a mixture. What I mean by that is, here is H2O. So in this case, we have 2 hydrogens. So this number, the number 2, applies to the letter before it. So 2 hydrogens and 1 oxygen, because no number tells me that there is 1 oxygen. If there's no oxygen there, we wouldn't add that letter O in there. That number can increase even more, so that number can be anything at all. So here's an example of CH4, 1 carbon, because there's no number after that, and 4 hydrogens, because this 4 applies to just the element before it. So the 4 here will only apply to the hydrogen. It will not apply to the carbon. There should be a 1 in here, but chemists usually don't write 1s. So how do we actually write this formula? Well, elements will bond in relation to the number of electrons they want to lose or gain, or technically share as well. Now, we can look at this in 2 ways. The first way we'll look at here is to do with the valency of an element. Now, the valency is just the number of electrons an atom wants to gain or lose in order to gain a full outer shell. The valency is directly related to the group the element is in, because every element within a particular group has the same number of electrons in its outer shell, and that's the shell you always want to complete. So simply, everything in group 1 is a valency of 1, group 2 is a valency of 2. I'll come back to this in a second. Everything in group 3 is a valency of 3, group 4 is a valency of 4, group 5, 3, group 6, 2, group 7, 1, and group 0 or group 8, depending on how you learn it, is 0. So in other words, your valency just goes 1, 2, 3, 4, 3, 2, 1, and then 0 for your noble gases. Now, this little bit about the transition metals, it says see the back of your data leaflet. Sometimes with transition metals, you'll be able to see a little Roman numeral here in brackets, and that Roman numeral is the valency. So this is 3, so chromium has a valency of 3. So let's put this into practice then with magnesium and oxygen. Well, magnesium is in group 2 of the periodic table, so group 2 of the periodic table will have a valency of 2. Oxygen is O, and oxygen is in group 6 of the periodic table, so its valency is also 2. The next thing we want to do is to simplify that ratio. So 2 to 2 will simplify down to 1 to 1. Lastly then, we want to cross over those valencies to tell us how many atoms of each element we need. So we're going to want 1 magnesium and we're going to want 1 oxygen. So my formula for magnesium oxide will be MgO, where I have 1 magnesium and 1 oxygen. However, if I was trying to write the formula for magnesium and chlorine bonding together to give magnesium chloride, it might be slightly different. Again, magnesium is still going to be in group 2 of the periodic table, so magnesium's valency is going to be 2. Chlorine, however, is in group 7 of the periodic table, so its valency will be 1. This time I can't simplify that any further, so I just cross my valencies to say I'm going to need 1 magnesium and 2 chlorine. So overall, my formula becomes MgCl2. So this small 2 telling me that I need 2 chlorine. The other way then to look at this is in terms of the charges, because of course elements become charged as they gain or lose electrons. Now, overall compounds are generally without any charge. They are completely neutral. So again, if we look at this in terms of charges, the charge of magnesium is generally Mg2+. The charge of an oxide ion is generally O2-. And if we want to get this to be neutral, then MgO, where you've 1 magnesium and 1 oxygen, will make these two charges cancel out exactly. 2+ cancels out the 2- to give you a 0 overall charge. However, if we look again at the example of Mg and Cl, well, Mg is Mg2+, as we said, a 2+ ion, whereas the chloride ion is generally Cl-. So to cancel out the 2+, you would need 2 of these Cl-, because if you have 2 Cl-, overall that would be 2-. So again, that's how we're going to get to that idea of MgCl2. We need 2 chloride ions to give me that 2- charge to cancel out the 2+ and give me something neutral overall. The first method, that is the valency method, is the method which is preferred by most people. The reason why I'm showing you this is this can be very helpful whenever it comes to molecular ions. So for something like SO4 2-, if SO4 2- is going to bond in with your magnesium, then it's going to be Mg2+ and SO4 2-. So you'll need 1 of each to cancel that out to give you MgSO4. Hopefully with that then, you now understand your chemical formula a little bit better.